So let me just tell you one way we're beginning to think about therapy now. What we'd like to do is delineate in a given disease, such as Alzheimer's, the disease-perturbed networks that occur initially, and then we'd like to be able to design drugs that can make those disease-perturbed networks behave in a more normal fashion, or at least abrogate their more deleterious effects. And this is a whole new strategy to the identification of drug targets, and we're testing these ideas in simple model organism systems now, and in 5 years we'll be ready to transform how drugs are going to be discovered, and we'll be able to do it really inexpensively. Now, the second thing we thought about from a systems point of view was diagnostics, because diagnostics is really going to be an absolutely critical key to understanding disease in the future. So we studied a particular neurologic degenerative disease in a mouse, and red indicates where the disease perturbations actually occur. And one of the first things we observed is if we looked at networks rather than the appearance of the mouse, we could actually see changes occurring 8 to 10 weeks before there were any clinical signs whatsoever. And we studied things at the DNA level in this initial series of studies, and we actually looked at a few of these altered things to see if proteins from those genes might show up in the blood, and they might be altered in the blood, and the answer was they were. But there was one more thing that we did that turned out to be even more powerful in that approach, and that is we again used genomic techniques to go to each of 40 different organs in a mouse and in a human and identify transcripts that were only made in that organ, and looked at the subfraction of those that can then be secreted in the blood. So one of our first studies, we've identified in humans now about 100 brain-specific blood proteins that constitute a molecular fingerprint. And what this fingerprint is going to do for us is really going to be spectacular. So if your brain is normal, those 100 proteins will all have their levels set at a specific level for each of the different proteins. But if your brain becomes diseased, some of those networks will change, and the cognate proteins for those networks will change their levels in a way that is characteristic of each different disease, because each different disease perturbs differing combinations of networks. So what this allows us to do is distinguish health from disease, and if you have a disease, we can determine exactly what the disease is. So this is going to revolutionize how we're going to think about disease, and as I'll say in a few moments, how we're actually going to think about wellness.